we have a function given to us, f of x equals to x to the 4th minus 4x cubed minus 8x squared, and we are asked to find relative extrema. Now you can apply the first derivative test, but in this video I'm going to show you how to apply second derivative test to find the extrema. That's not how you spell derivative. D-E-R-I, derivative test to find the extrema. And if you remember from the last video how you apply the second derivative test, first of all you find values where f prime equals to 0. Find values where f prime is equal to 0, and then you're going to find f double prime, and we're going to plug in the values from part 1 to f double prime that we found in the step 2. Again, first of all you find all values such that f prime is equal to 0. Second, you find f double prime, and you plug in the values from part 1 into part 2. And if f double prime is positive, that means the graph goes like this and you have relative minimum. And if f double prime is negative, that means the graph goes like this and you have a maximum. If f double prime is 0, the test fails and you have to use first derivative test in this case. Let's try out an example shown right here. We start by finding f prime. F prime of x is going to be 4x cubed minus 12x squared minus 16x. Let's factor out 4x. 4x times x squared minus 3x minus 4. We can factor the expression x minus 4 times x plus 1. So where are the values such that f prime is equal to 0? Well, I see x equals to 0, x equals to 4, and x equals to negative 1. So these are the values that we have to find in part 1, where f prime is equal to 0. Now we're going to consider finding f double prime and plugging in those values. F double prime of x, using this, is going to be 12x squared minus 24x. You can factor it if you want to 12x times x minus 2. Now what do we have to do? We have to plug in the values into f double prime, and we have x equals to 0, x equals to 4, and x equals to negative 1. Let's try it out. F double prime and negative 1 gets you negative times negative, so that's going to give you positive because it's negative times negative. F double prime at 4, I'm going backwards here, negative 1, 4, and 0. You don't have to. F double prime at 4 is going to be positive times positive, and that's going to get you positive. And f double prime at 0 gets you 0 times negative, or 0. Now what can we conclude? Well, f double prime and negative 1 is positive, and if f double prime is positive, that means relative minimum, and same thing applies to f double prime at 4. Now what can we conclude about f double prime of 0? You kinda cannot conclude anything because f double prime is 0 and the test fails in this case. So in this case we have to use the first derivative test. So let's apply this. Let's put f prime, and we have negative 1, 0, and 4 as our critical values. So negative 1, 0, and 4. All we have to do, we already know what's going on at negative 1 and 4. So all you have to do is to find the sign in between negative 1 and 0 and find the sign that goes in between 0 and 4. In between 0 and negative 1, you can pick negative 1/2. Plugging that into f prime, you have positive times negative, and that's going to get you positive. Between 0 and 4, you can pick 1, and you get positive times negative times positive, which is negative. Since f is increasing to the left of 0 and decreasing to the right of 0, we know at 0 you have a relative maximum. So what do we know? We know at x equals at negative 1 and negative 1 there is a minimum. At 0 there is a maximum, and at 4 there is also a minimum. You can plug in the x values into the original function and find the y if you want to find the points. Now let's look at the graph and see if our answers are correct. This graph is from Desmos.com, and as we can see, at x equals to negative 1, we have a minimum, At x equals to 0, we have a maximum. And at x equals to 4, this graph goes way down until negative 128. And you once again have a minimum again.